Alright, 4-6, let's go ahead and wrap up what we need to do here in chapter 4. We are doing 3x3 matrices. Last time we did 2x2, so this time we'll make it a little bigger, 3x3. Their determinants and their inverses. So what we're going to learn, we're going to figure out how to find the determinants of a 3x3, and then we'll use inverses to solve matrix equations. Very similar to what we did in 4-5 with 2x2s. Alright, so we need to have a couple skills in here, and so to find the determinant we need to be able to multiply some varying things inside of a matrix. So your job here is to multiply the colored numbers in each matrix. Just multiply them together, that's all you have to do. You'll see why in a second. Take a second, do that. Alright, so let's figure out how we evaluate a determinant. So last time it was easy because it was just down minus up, but now we've got more cells to deal with, more elements to deal with. So here's how it works. We're going to do all the different ways we can go down. So the first one's easy because it just runs straight across. A1, B2, C3, and that's here. Then we got to combine it with, if we started here going down, B1, C2, we would run out, so we got to loop around to A3. So it's B1, C2, and then the next one we would hit is A3. So we come back around, that's this one here. And then C1, if we started going down, we run out, so if we started back over, we'd hit A2 and B3. So you can kind of see the patterns here through the middle, B1, C2, and A3, and C1 and A2, B3. Multiply them all together and add them up. And then minus, we're going to put all these things together, so now we go up. This diagonal going up, A3, B2, C1, B3, C2, and if we wrapped around again, we'd hit A1, and then C3, and if we wrapped around, we'd hit A2, B1. So that's here, C3, there it is, A2, and B1. So we'll do an example here. So let's see, going down, we've got -1, -4, -1. That's here. We've got 3, 6, 0. So that's here. And we've got 5, 2, and 1. 5, 2, and 1 match up. So multiply them all, add them up. We get -4, 10, and 0, which is is positive 6. Now we're going to subtract the ups. 0, -4, and 5, that's 0. 1, 6, and -1, that's -6. -1, 2, and 3, that's also -6. And so we put those together, we get -12. Subtract them, and we get 18. Alright, so a little tricky at first to remember the patterns, but if you go slowly, try it, I think you can do this. Find the determinants for A, B, and C. Alright, so for the inverse, we can use the calculator here to figure out the determinant, and it's showing you the steps here. If we go into math, which on our graphing calculator is just right here, click math, and you'll see here that we need to go, in matrix, which is right below math, we need to go over to math inside matrix, and there's our determinant there. We can hit that, and then we can figure out any of our matrix determinants. So I think I have some stored in here. Yep. Let me figure out the determinant of A that's stored in there, and it would give me a number. Right? So on this one, the determinant of a 3x3, a little tedious to do by hand, we can punch it into our calculator as well. Alright, so go ahead and see if you can come up with the right answer for the determinant of this matrix. Use your calculator. Alright, so now that we know how to do the determinants, we're going to do the inverses. And for the inverses, we're strictly going to be using the calculators here. We're not going to do these by hand. So first things first, we want to verify that these two are inverses of each other, multiplicative inverses. Remember, if we multiply them together, we should get 1s on the diagonal, and we do. C and D, if we check, we should get 1s on the diagonal. We don't, so C and D are not multiplicative inverses of each other. Alright, so verify A and B, and verify that C and D are either inverses, and then C and D are not inverses, so you should not come up with the identity matrix. Alright, and so here's an example. We can do it on our calculator. Remember, to get rid of this, we would multiply by the inverse, so we need the inverse of A, and then times it by the 6, -11, and 8 matrix. Do that, and we end up with 1, -2, and 3. So those are the steps. Using your calculator, see if you can solve this equation. Okay. Alright, so last one, I kind of like this one. This is a decoding type problem. So in this problem, they give you an alphabet, and they give you a encoding matrix. Alright, so what you need to do to decode this matrix is find the inverse of E. So if we punch this into your calculator and do the inverse, this is what spits out. And then if you're given the code, here's the code, 22.5, 26, 15.5. If you multiply this times the inverse, it'll spit out numbers. Those numbers match up to the letter. So here's our final answer. 14 matches up with M. 26 matches up with A. And you keep going, you're going to get M-A-T-R-A. Look at that, it's going to spell matrices. Alright? So your job, is to decode this. So remember, use the inverse, times it by this, and each answer that you get is going to match up with a letter. See if you can find the title of a Pablo Neruda poem. Interesting. All right. So any questions, we're going to go over it in class, but that's the end of 4-6. Good luck.